Now let's recall concepts of value mixture and uniform motion problems.
Okay, so for value mixture, it's going to be, again, it's going to be the amount of material that we use, in this case peanuts for example, times amount of material times what? Unit cost of material. Unit cost of material is equal to value of the material. Value of material. All right. So here's the variables we'll use. We'll use A times C for cost, unit cost. So amount of material is A. Unit cost of material C is equal to V, that total value of the material. Okay. So we'll use this A times C equal to V equation in our table setup here. All right. Let's look at a problem then. So basically, here's the basic setup. I'll give you a problem on it in a moment here. But here's the table setup for a typical mixture problem, if you will. Now it's going to be it's going to have 4 rows in it. Okay, so make a table with 4 rows because I need to account for the mixture as well. So here's what I mean by that. So in a typical problem, the setup is something like this. So it'll be amount, all right, times unit cost. You can use A times C if you want to abbreviate. That's fine too. And I'll probably do that later on as well. Is equal to value of material. Okay? So what goes in these boxes? Well, this is material 1. Material 1 and material 2. So for example, peanuts here, walnuts here, and down here, the resulting mixture. Okay, so material 1, material 2, and the mixture. Okay, so you fill out one column at a time. Again, anything we don't know, we introduce a variable, and then we get the third column by what? Multiplying the first 2 columns. So amount times unit cost is equal to what? Value. So this has a familiar theme with the previous problems we've seen. Again, remember for investment problems last time, it was what? It was principal times the interest rate is equal to the interest. So it's all multiplication here. Again, the last column is what? The product of the first 2 columns. Okay? So let's look at a problem involving this table setup here and see how we can solve these value mixture problems. All right? So let me go and clear this out. Okay, let's look at this example right here. Okay, so this one says what? How many ounces of pure gold that costs $3.60 per ounce must be mixed with 30 ounces of an alloy? Sorry about that. That should be a Y there. Be a Y there. Of an alloy that costs $2.40 per ounce to make an alloy costing $3.20 per ounce. So that should be a Y there. Okay, so how many ounces of pure gold that costs $3.60 per ounce must be mixed with 30 ounces of an alloy that costs $2.40 per ounce to make an alloy costing $3.20 per ounce? All right. So let's see. So first step is what? Let's make the table here and identify the types of material that we're using here. Let's make a big table here. Let's be real neat about it. Take our time. 3 rows in it. Alright, so there's that. Sorry, 4 rows I meant to say. Alright, so because the top row is the formula here, so amount of material, alright, times the unit cost of the material is equal to the value of the material. Okay, so what goes in these 2 boxes? Well, the types of materials we're mixing. We're mixing what? Pure gold with an alloy. Okay, so pure gold. So identify the materials first. All right, pure gold with an alloy to get some kind of mixture out of that. Okay, so we have pure gold, alloy, and mixture. All right. So again, sorry for the handwriting here. All right. So let's look at the amount column here. All right. So what do we know? Well, it says how many ounces of pure gold. So I don't know how much pure gold I want to use, right? So let's make that X. Again, introduce a variable since we don't know how many ounces of pure gold. And that's what we're trying to find out here. All right. That costs $3.60 per ounce must be mixed with 30 ounces. So 30. So look for all the amounts in this problem, right? Skip over at $3.60. That's the unit cost. So that's the next column. But don't worry about it. Fill out one column at a time. All right. Don't jump all over the place, otherwise you end up confusing yourself. So look for the amounts first. So look at this 30 ounces. That's an amount figure. So it says must be mixed with 30 ounces of an alloy. So this alloy, we're using 30 ounces of it. All right? And so if I use X ounces of pure gold and 30 ounces of this alloy, then the mixture is going to have what? Well, it's going to have X plus what? Plus 30, right? X ounces plus 30 ounces there. So the total weight, the total amount of the mixture will be what? X plus 30. Can we see that? All right? So for example, in the previous example, I have peanuts, 4 pounds, walnuts, 6 pounds. That's a total of what? 10 pounds. All right? Let's look at the unit cost here. So pure gold is going to cost what? $3.60 per ounce. So that's going to be $3.60. All right? $3.60 here. All right? And how about the other alloys? Well, it costs $2.40 per ounce. So this alloy is $240 per ounce. Now I want to make an alloy. I want to make a mixture. This is my mixture here. This is my alloy mixture. To make an alloy costing $3.20 per ounce. So the unit cost for the mixture will be $3.20 per ounce. Now notice the 320 makes sense, and let me tell you why. What if this number is not 320? What if this number is 380, for example? Well, 380 would not make sense, for example, because pure gold already costs 360. I know gold's a lot more expensive now than it used to be, but so this problem is a bit dated, but maybe gold will come back down. All right, that's on the side note. But the most we can get out of it is 360. That's the highest number. And I'm mixing it with a material that costs only $2.40 per ounce. So it makes sense that my mixture will be somewhere in the middle of the cheapest material and the most expensive material. Does that make sense? Again, so 320. So this number down here, the cost the unit cost, or the cost per ounce for the mixture, should be in between 240 and 360 is what I'm trying to say. So if I get 380 down here, that makes no sense. If I get 220 down here, that makes no sense, because that should be higher than the 240, and it should be lower than the 360. Okay, so again, the number you get for the unit cost in the mixture should always be between the two numbers in terms of material here. These two numbers. All right. So let's look at the value then. All right then. So just multiply, right? So X times 360, 360X. 30 times 240, punch on the calculator. 7,200. So 7,200. And then 320 times X plus 30. All right? Now, so 320 times the quantity X plus 30. Okay, so let's go ahead and look at the equation again. So I mentioned this is the total value of the pure gold. This is the total value of the alloy that we're using to mix with the pure gold. And this is the total value of the mixture. All right. Remember in the previous example how I added the peanuts and walnuts together to get the value of the mixture? That because what we get out of it is what we put into it. So therefore, the sum of these two values here will be equal to the value of the mixture. Again, the value of the mixture is always the total value. Okay, so again, keep that in mind. Value of the mixture is always the total value. So therefore, the equation we're solving is 360x plus 7200 equal to 320 times x plus 30. All right, can we see that? Okay, so that's the result that we get here in terms of the equation. So let's go ahead and finish solving this equation. So 360x plus 7200 equal to 320 times x is 320x, and 320 times 30, punch out the calculator, 320 times 30, that's equal to 9600 plus 9600. No big deal, take your time with that. Let's get x on the left, numbers on the right. So let's subtract 320x on both sides here to get it over to the left side, if you will. Make sure we're sharp on equation solving. That's 40x plus 7200 is equal to 9600. All right. Subtract 7200 on both sides to get it over to the right side. Numbers on the other side. All right. So I get 40x is equal to what? 2400. All right. And dividing both sides by 40 to solve this equation, then I'm going to get 60, I believe, right? So 2400 divided by 40 is going to be 60. So therefore, we get x equal to 60. All right. So it says what? How many ounces of pure gold do we need? Well, we need, and x is the amount of pure gold that we need here. So we need 60 ounces of pure gold to make this mixture of pure gold. All right, so that's our solution, 60 ounces of pure gold. Again, you want to practice setting up this table here. Get material 1, material 2, mixture, and then amount times unit cost equals what value. And we fill out one column at a time here. All right, let's try another one here. Let's try another one. Let me clear out this table. All right, let's look at this example right here. All right, a grocer combined peanuts that cost $5.20 per kilogram with cashews that cost $6.40 per kilogram. How many kilograms of each were used to make a 45-kilogram mixture costing $6 per kilogram? All right, so let's go and make a big table once again. This time I'm mixing what? Peanuts and cashews here, okay, versus peanuts and walnuts like we had last time. All right, so let's make a nice table here with 4 rows in it. Take our time with that a little bit. All right. Okay, so the amount times the unit cost, all right, is equal to value. That's the key idea, right? Amount times unit cost equals value. Keep this formula in mind. It's just more standard multiplication, right? So we're mixing what? Peanuts and what? Cashews. All right, I have my resulting mixture. All right, so peanuts, cashews, and mixture. All right, identify the materials you're mixing and the resulting mixture. All right, so how much are we using of each? Well, what do we know about that? Well, it says a grocer combined peanuts that cost $5.20 per kilogram with cashews that cost $6.40 per kilogram. So we don't know anything about the amount of peanuts or cashews we're using here. All right. So, however, look at this one. How many kilograms of each were used to make a 45-kilogram mixture? So I do know the amount of my mixture is 45 kilograms. So I do know that I want to make a 45-kilogram bag of peanuts and cashews. But again, of the 45 kilograms, excuse me, I don't know how much will be peanuts, how much will be cashews. So let's make one of them X. Let's say of the 45 kilograms, X kilograms will be the peanuts. That means how many cashews, what's the amount of cashews? Well, it's going to be 45 minus X. Can we see that? Not too bad now, because the total is 45, right? So peanuts cost what? $5.20 per kilogram, $5.20. And cashews cost what? $6.40 per kilogram, a little more expensive for the cashews. And the mixture is going to cost what? Well, $6 per kilogram. A 45-gram mixture costing $6 per kilogram, so $6. $6. All right. Then multiply the 2 columns to get the last column. So 520 times x is going to be 520x, or 5.2x if you will. And 640 times 45 minus x. All right. So 640 times the quantity 45 minus. Just multiply these two together. Okay. So let's look at 45 times 6. So 45 times 6 will be 270. So the total value of this mixture will be what? 270. So again, we get out of it what we put into it. So let's add up these first 2 values to get the last value. Again, the value of the mixture is always the total value. All right. So let's go ahead and figure this out. So the equation we get is 520x plus 640 times 45 minus x. Sorry for the ice cream truck going by here in the outside, so bear with me on that. So 640 times 45 minus x, and that's the value of the what? Of the cashews. The 520x is the value of the what? The peanuts here. And that's equal to total value, which is what? 270. All right? So let's go and solve this equation. So we have 520x plus, what is 640 times 45? Punch in the calculator, times 45. That's 288. So that'll be 288. 640 times negative x, negative 6.40x equal to 270. All right? Combine like terms. 520x minus 640x will be negative 1.2x. We punch 5.2 minus 6.4 in the calculator. All right, plus 288 equal to 270. All right, subtract 288 on both sides. You clearly hear the ice cream truck in the background, I suppose. All right, negative 1.2x is equal to what? Negative 18. All right, so let's divide both sides by negative 1.2 here. All right. So x will be equal to 18 divided by 1.2. So that's going to be 15. Okay, so that'll be 15. 15 what? 15, x is what? X is the amount of peanuts in what? In kilograms. So that's 15 kilograms. So we need 15 kilograms of peanuts to make this mixture, right? How many cashews, how much cashews do I need? Well, 45 minus 15, so 30. So I need 30 kilograms of cashews, all right, to make this mixture. So 15 kilograms of peanuts and 30 kilograms of cashews, again, to make this 45 kilogram mixture that will cost $6 per kilogram. All right, so again, using this table to set up this problem. Okay. All right, let's look at the concept of uniform motion here. So if you recall, that uniform motion is based on the distance equation. And that says that distance is equal to rate times time. D is equal to RT, as we presented previously. All right, so let's look at an example of a uniform motion problem in this section here. All right, so consider this problem here below. So it says, two cyclists start from the same point and ride in opposite directions. One cyclist rides twice as fast as the other. In 3 hours, they are 81 miles apart. Find the rate of each cyclist. So let's get an understanding of this problem by making a simple picture here. So suppose I use a dot to represent the first cyclist, and they're riding up, and another dot for the second cyclist. All right, and they're going to ride in opposite directions. So let's say cyclist 1 goes in that direction, cyclist 2 goes in the other direction. All right. Now it says in 3 hours they are 81 miles apart. So let's go ahead and look at how we can answer how fast each cyclist is going. So let's put that equation here into a table. Let's make a table of 3 rows and 3 columns. All right. So let's make a nice box here. Do the best you can. All right. 3 rows. All right. And actually more than 3 columns, actually, I should say. So the first column will leave blank. Second column will put the equation in. Rate, all right, times time equals distance. All right, so there's our equation there, all right? So let's go ahead and fill in this table here. The first column here, actually we are going to fill in these 2 boxes right here. So these will be the objects in the problem. In this case, the 2 cyclists will be the case here. So that'll be cyclist 1 and cyclist 2. All right. So the rate of each. Now we don't know that. So let's go 1 column at a time. For each column, where we don't know, we introduce a variable. In this case, our variable falls in the rate column. So look at this problem again, real carefully. It says one cyclist rides twice as fast as the other. So what that tells us then is that one of them is twice as fast as the other. So, but we don't know how fast one of them is going. So let's introduce a variable. Let's say cyclist 1 is going at r miles per hour. And cyclist 2 is going to be twice as fast as that. So his speed will be 2r miles per hour. All right? So let's look at the time column. It says in 3 hours, they are 81 miles apart. So they're each going to ride for 3 hours. So 3 hours for cyclist 1 and 3 hours for cyclist 2. So in other words, in 3 hours, cyclist 1 goes this far, cyclist 2 goes that far, for example. All right, but together they are 81 miles apart. All right, so therefore, let's calculate the distance of each cyclist. Right, so cyclist 1 goes rate times time is distance, so r times 3 is 3r, 2r times 3 is 6r. So there are their respective distances. But we know that the sum of their distances from this picture will be equal to what? 81 miles per hour. So it'll be 3r plus 6r, that sum of their 2 distances will be equal to 81. All right? Let's go solve this simple equation here. So combine like terms, we get 9r equal to 81. Dividing each side by 9. So we're going to get r is equal to 9 miles per hour. All right? And that's the speed of which cyclist does. Well, that's the first cyclist, as you can see, right? Because his speed is what? R miles per hour. The second cyclist will be 2r, so twice that. So it will be 2 times 9, because since r is equal to 9, and that's equal to 18 miles per hour. So first cyclist goes at 9 miles per hour. Second cyclist goes at 18 miles per hour. Let's look at another example here. All right, let's look at the second example right here. Consider this problem, and let's look at this problem here. So it says Tim and Helena are at opposite ends of a 12-mile country road with plans to meet for a picnic lunch. Tim starts out jogging at the rate of 5 miles per hour, while Helena rollerblades at a rate of 7 miles per hour. How long after they begin will they meet? So here's a nice simple picture here. So here's what's happening in this problem. So let's say here is Tim here. All right. Let's say here is Helena. Right? And how far are they apart? Well, they're what? 12 miles apart. They're on opposite ends of a 12-mile country road. So they're 12 miles apart. And they're going to head towards each other to meet. All right? So let's look at the setup here, if you will. All right, so let's look at make a nice table here, if you will. 3 rows in it. Just do the best you can. All right, so then we have rate, put the equation in, times time is equal to distance. All right, so let's put in the 2 objects. In this case, Tim and Helena are involved in the problem. So Tim and Helena. All right, so let's look at the rate of each. Well, Tim jogs at a rate of 5 miles per hour. So in this case, the variable is not in the rate column. Helena rollerblades at a rate of 7 miles per hour. All right. Question though is asking us how long after they begin will they meet? So that's a time question, right? So the variable will be the time, right? Now, what that's asking though is that if when Tim and Helena take off at the same time, how long after they take off will they meet somewhere in the middle right here? All right. So that means they each have to travel for the same amount of time before they meet in the middle. So let's make that time t, for example. So let's let t be the time that Tim will have to jog to meet Helena. And likewise, t will also be the time that Helena has to rollerblade to meet Tim. All right? So let's multiply the rate and time to get the distance of each person. So Tim's distance is going to be 5t. And Helena's distance is 7 times t, which is 7t. All right? Now, again, Tim will cover that distance. Helena will cover the rest of this distance. But together it's going to be how long? How far? 12 miles per hour. So, therefore, the equation we get again will be the sum of their distances. 5t plus 7t will be equal to 12. And let's go and solve this equation. 5t plus 7t is 12t equal to 12. As you know, dividing by 12, we're going to get t equal to 1 hour. All right, so 1 hour after they leave, will they meet in the middle for a picnic? All right, so that's basically our solution here for this problem. All right, let's go ahead and let me pause again and put up one last example before we move on here. All right. All right, let's take a look at this last example we have for you on uniform motion. So let's look at this problem here. So it says, at 10 a.m., a plane leaves Boston, Massachusetts for Seattle, Washington, a distance of 3,000 miles. 1 hour later, a plane leaves Seattle for Boston. Both planes are traveling at a speed of 500 miles per hour. How many hours after the plane leaves Seattle will the planes pass each other? So again, let's dissect this problem bit by bit. Don't try to absorb this problem all at once. Otherwise, you'll end up getting overwhelmed by the information presented in this problem. So let's go ahead and look at a simple picture once again. All right, so let's go ahead and say, here is the, let's make it geographically correct as well. So let's say here is Seattle on the west coast, if you will. And let's say here is Boston, Massachusetts, on the east coast. All right. So it says what? At 10 a.m., a plane leaves Boston for Seattle. Right. All right. So a plane leaves Boston for Seattle. So plane 1 will go from Boston to Seattle. So plane 1 goes that way. So this is plane 1. P1 for plane 1. All right. And then it says 1 hour later, a plane leaves Seattle for Boston. So the second plane will be from Seattle to Boston. So that goes to Boston. All right, that's plane 2. All right. So let's go and look at the table setup for this. Then let's make a nice big table here. Real big table, 3 rows in it. again, rate, put the distance uniform motion equation in, rate times time equals distance. Alright, so let's put the two planes in. So here's plane 1. Keep in mind that plane goes from Boston to Seattle. Alright, and plane 2, keep in mind that plane goes from Seattle to Boston. Alright, so let's look at the rate of each plane. So that's what both planes are traveling at a speed of 500 miles per hour. So it could be 500 miles per hour for each plane. Not too bad. Alright, 500 miles per hour. Alright, says, now the question is, how many hours after the plane leaves Seattle will the planes pass each other? So this is asking you how many hours after the plane from Seattle takes off will the planes pass each other. That's the second plane here. So in other words, how many hours after plane 2 leaves will the two planes pass each other in the air? Alright? So we don't know that. So let's let that be t. So let's make that t here for the time that after plane 2 leaves will the two planes pass each other. Alright? Now keep in mind that this second plane leaves 1 hour later after the after the Boston plane left. Alright? Which is 1 hour later, the plane leaves Seattle for Boston. So plane 2 leaves later than plane 1, which means that plane 1 had a 1 hour head start. So since plane 2, if plane 2 is going to be in the air for t hours, then plane 1 will be in the air for 1 hour longer than that, so t plus 1. Alright, so that's a challenging concept. So you can try to understand this concept here and replay this video, replay this problem if necessary. Alright, let's calculate the distance of each plane then. Alright, so the distance for plane 1 is 500 times t plus 1, and the distance for plane 2 will be 500t. Alright, so let's go ahead and look at the equation that we get from this table then. Alright, now the distance apart is going to be what? For two cities, what? 3,000 miles apart these two cities are. So 3,000 miles. Alright, so therefore the equation we get once again would be the sum of their distances, as you can see from this picture. So it's going to be 500 times t plus 1 plus 500t is equal to 3,000. That's the equation we need to come up with and solve in this problem. Alright, so we're going to solve it real quickly. So distribute the 500, simplify the left-hand side. 500 times t is 500t, and 500 times 1 is 500, alright, plus 500t, equal to 3,000. Alright, let's go ahead and combine like terms. So 500t and 500t is 1,000t, plus 500 is equal to 3,000. Alright, so it's going to subtract 500 on each side. As you know, should be sharp on equation solved by now. So 1,000 t is equal to 2,500, and dividing both sides by 1,000, then we're going to get the answer, and reducing that fraction as well. That's going to be 500 goes into both of these numbers, 500 to 2,500 5 times, 500 to 2,000, 1,000, excuse me, 2 times. So this is 5 over 2, or 2.5 hours, if you will. Alright, so that tells us that after the plane leaves Seattle for Boston for 2.5 hours, the two planes will pass each other in the air. So the answer we're looking for is going to be 2.5 hours. So 2.5 hours. The two planes will pass each other after the second plane takes off. So that's our solution right here. Alright, so hopefully you understood this problem. Again, replay this lecture video if you need to. Hopefully you'll put more time into understanding this problem here. You may have to read it several times, but the key is to dissect this problem bit by bit, as I did here for you.
Here are the Blackboard problems for this section. Let's take a look at these three problems here. All right, so number 1, find the cost per liter of a mixture made from 70 liters of cranberry juice that costs $1.20 per liter and 130 liters of apple juice that costs 80 cents per liter. All right, so value mixture problem. Number 2 and 3 are uniform motion problems. Number 2, two cars when traveling 12 miles per hour faster than the other start at the same time from the same location and travel in opposite directions. In 4 hours, they are 384 miles apart. Find the rate of each car. All right, use the table set for that as well. And number 3, a pilot flew from one office to another. The average speed going was 320 miles per hour, while the returning speed was 480 miles per hour. Find the round trip distance if the total flying time was 5 hours. So based on this information, so you can find the round trip distance for this pilot here. Right, using the rate times time, you go to distance uniform motion table. Right, so post these answers into Blackboard, and we'll go over it in class. Until next time.